Okay, so we're going to begin, just to fill people in that aren't here. We're now starting chapter 12. We're going to learn chapters 12.1 through 12.5. Juniors will take a summative on chapter 12. The seniors will review chapter 12 with us, but then they'll just be taking their final exam. So you are finished with summatives for the trimester until your final exam. All right, so moving right along, we miss you guys. Okay, so arithmetic sequences and series, this is something that you likely have seen before in Algebra 2, but we're going to get into it a little bit more again. So arithmetic sequences and series is all about patterning. Right? And you're going to look for various patterns. So here you have, what is the difference between a sequence and a series? Any thoughts?
Sequence, it goes forever, when a series is only like a set amount of numbers.
No, but it's a good guess. A sequence is a list of numbers. Okay, a series is when you're adding all of those numbers together. Okay, so a list of numbers arranged in any order that obeys a certain rule is a sequence. And we can list these sequences using first term, second term, third term, something like that, okay? And of course, if it goes on forever, you want to use the ... to indicate that it's continuing on, okay? It's also referred to sometimes as an element of the sequence or a member of the sequence. Okay, so each number in the sequence is a term. In an arithmetic sequence, you have values, terms that you're adding together. Okay, so the same number of the term added to the other one, and it's going to be constant. That's called a common difference if you're adding the same amount each time. Okay, so for example here, we're given this list of values. What is the common difference? 3, right? Because each time you're adding 3. Okay, so you could call 3 the common difference. Just going through some vocab so that you understand what's going on. Okay. So in example 1, it says find the next 4 terms in the arithmetic sequence. So that is our hint right there, that it's arithmetic, meaning, oh, that's kind of funky, that that you're adding, okay? You're going to be adding the value. So what is the same value that we're adding between each of these? Right, 3. So if I need to know the next 4 terms, I have -5, -2, 1, and I need the next 4 terms, what would they be?
7, and then 15.
Perfect. Okay, not too difficult. Are you guys okay with that? Okay. So this is the general form for an arithmetic sequence. The nth term of an arithmetic sequence with first terms A1 and common difference D is given by A sub n equals A1 plus the quantity n minus 1 times D. Right, so we're going to be using this formula again and again in order to figure out various aspects of an arithmetic sequence. All right, so let's try it with example 2. So find the 47th term in the arithmetic sequence. So I'll write the formula down first. So is A sub n is equal to A1 plus n minus 1 times D, right? What is our n in this case? That's the number of the term that we're looking for, okay? So what is that?
47.
All right. So we have a sub 47 is what we're looking for, the 47th term. What is our a1? -4, the first term. Plus, we already said our n is 47. And what is our d? -3. -3? Right. Okay. So I can say plus 3. So I know now that my 47th term is going to be -4 plus 46 times 3. And that gives us 134. Okay, so the 47th term in this sequence is 134. Beats adding 3 another 40-something times, right? Okay. So here, now we want to use the same formula. A sub n is equal to a1 plus n minus 1 times d, but they want us to find the first term given all of these other terms, right? So we know the 19th term. We're trying to find a1. That means our n is going to be 19, and our d they give us as -2/3. So we have 42 is equal to a1 plus 18 times -2/3, 6 times, so -12, right?
Like, why didn't you put 42 in first for the A19? Like, why wouldn't 42 go in for, like, you see how you have 19 minus 1?
Like right away here?
And the other one, right next, like 2 spots down, 19 minus 1.
Okay, so...
Like, why did you put 42 there?
Okay, so I put, there's a pointer on this thing. Is this the pointer? Yeah, okay. So I put, look at your original equation. AN is what's given to us here, right? So if I plug in here, that's telling me that my n is 19. So if I look at my equation, I'm going to replace n with 19. And then I'll have this value, because that's given. A1 is what we're looking for. 19 is n, and our d was also given to us, right? Does that make sense? So you're just going to substitute those values in, and then you're going to solve for that A1. Okay? All right. I don't know how much of that missed in the recording, but we'll see. Okay, so for example 4, it says to write an arithmetic sequence that has 5 arithmetic means between 4.9 and 2.5. So this is another combination of using that formula, right? So let's set that up first. The first 5 terms, right? So we have A1, A2, A3, A4, A5. And we have 4.9 as our A1, and we have 2.5, right? An arithmetic sequence that has 5 arithmetic means between them. So maybe it's actually a little bit more, right? So this is 1 here, 2, 3, 4, 5 is going to bring us to A6, right?
So A6 would be 2.5.
Did I do that right? 1, 2, 3, 4, 5. Yeah. Okay, so 2.5, yeah. And we're going to have to figure out what these values are in between, right? Okay, so we have to figure out what that D is, right? How can I do that? Like if I'm starting with 4.9 and I'm ending with 2.5, I want to find the difference between them. So 2.5 minus 4.9, and we're dividing 5 times, right?
Why wouldn't it be 4.9 minus 2.5?
Well, you want to do it's not the greatest value because it's actually a lower, but the last one in your series minus your first one in your series. Okay? Because in this case, that's how we know that it's actually going down, because we're subtracting a little bit each time, right?
Yeah.
Okay. If we make it the 6th term, it might be a little bit better because the number's a little cleaner. What do you want to do? Leave it? Okay. All right. So then if we do this, then we get negative 0.48. So that means if I do 4.9 minus 0.48, I have 4.42. Right? So each time I'm going to subtract minus 0.48. And if I do that, minus 0.48, 3.94, minus 0.48, 3.46, minus 0.48, 2.98, and I should be able to subtract one more time and get 2.5. And it's worth doing the extra time to make sure that you've done it correctly, right? Okay. So now I can look at this and I can say I have my A6, and that's equal to 2.5. And I know that that has to, like, if I think I want to rewrite. If I have it like A6 is equal to A1 plus N minus 1 times D, I know my A6 is 2.5. I know that my A1 is 4.9. The number of sequences was what? My N, in other words, right, was 6. And I could figure out what my D is dependent on that. It's another way of finding the D instead of having to write out the way we did it the first time. So if I have the 47th term, it's a lot faster to do this bottom method, right? So 2.5 is equal to 4.9 plus 5D. And if I solve for D, I'm going to have 2.5 minus 4.9, and then I divide by 5, and I should get negative 0.48.
So what's the end? Because it's telling you to write an arithmetic sequence.
Right. So, all right. So if you were given just this information, instead of having to do this original method, since it's the 4th of May, we should use our lightsabers, right? There's a sound to it. How fancy. May the 4th be with you. I got to turn this volume off, though. It's going to, yeah, that would be really bad. Okay. Anyway, so the whole point is that, like, this top stuff, you shouldn't have to waste your time with. You should be able to use this actual formula here. That's actually really annoying. But you should be able to use this formula right here. So I know that 4.9 is my initial value and 2.5 is going to be my end value. I know that I have 5 arithmetic means, right? And so I can use all of this information here to figure out what my D is and then be able to subtract it each time to get to the next value.
You're showing us two ways to find D.
Exactly. Okay. All right. Are we good with that? Okay. So now that we know what a sequence is, let's look at what a series is. So an arithmetic series is when you're adding all of your sequence values together. A list of numbers is your sequence. When you sum them together, that's a series. Okay? So, and then there's an equation for that as well. So the sum of a finite arithmetic series, the sum of the first n terms of an arithmetic series is given by this equation, okay? If this first one you want to use if n and a1 are and an are given. Okay, and then the second one here, if n, a1, and d are given. So this one, the difference is the an, and this one, the difference is the d. It just makes it easier. And really, if you look at it, all the difference is this, this an here is equal to this, right? So it's just substituted. It's not like you're memorizing a whole new thing. Okay? So in example 5, we're finding the sum of the first 60 terms in the arithmetic sequence. So if you add the first 60 terms, you get 9,390. That's it. Beats adding them all out, right? So it's worth knowing the formulas. Okay, so we'll try example 6. All right, so the full question is, Ophelia Gonzalez sells houses in a new development. She makes a commission of $3,750 on the sale of her first house. To encourage aggressive selling, Ms. Gonzalez's employer promises a $500 increase in commission for each additional house sold. Thus, on the sale of her next house, she will earn $4,250 commission. How many houses will Ms. Gonzalez have to sell for a total commission in 1 year to be at least $65,000? So we need to take that total amount that she's trying to reach, $65,000, and we're trying to figure out how long that would take, right? So we'll say n over 2, and we're going to use that other formula, 2a1 plus n minus 1 times d. And what do we know already? We know, and maybe you don't remember because I just read off 5,000 values to you, but we know n is what we're trying to figure out. We know that she started A1, it said, was $3,750 plus, there's that n again, so we'll leave that. And then it said that she was going to make a commission or increase $500 in commission for each additional house. So that's our D. That's what we're adding to each value. Okay? And from there, it's just a matter of doing the math. So I don't like fractions. I'm sure you don't either. So let's multiply each side by 2 so that we don't have that fraction there. So that's going to be 130,000 is equal to n 2 times 3750 is 7,500. I'm going to distribute the 500 there. So plus 500n minus 500. We all okay? Okay. So I'm going to just clean up a little bit in the parentheses. So I have 7,500 minus 500 is 7,000 plus 500n. And I can distribute my n there. So I have 130,000 is equal to 7,000n plus 500n squared. So I have a quadratic, basically. I just have to set it equal to 0, right? So I have 500n squared plus 7,000n minus 130,000 is equal to 0. And then I can use my quadratic equation. Who wanted to sing the song?
Will you go up just like a tiny bit so I can see the line?
Sure, let me just finish writing this. Uh-huh. All right, so if you do solve it out, then you have, well, in this case, it's actually n, right? So n is equal to, you get two values because it's quadratic. So you get 10.58 and negative 24.58. And of course, we're going to get rid of the negative, right? Because it's how many houses you have to sell. So how many houses would she have to sell in order to make that commission?
11 houses.
11 houses, right?
Hello everyone, I just wanted to remind you all that tomorrow is the last day to donate for the Peru flood donation drive. The things that you can donate.
Because obviously we can't sell 10.58 parts of a house.